Okay. So, yesterday, I think the last thing that we were writing down is this right here. We were talking about amplitude. Amplitude is vertical stretch. And the reason that we call it amplitude and not vertical stretch is because we share terms of science class for these. These are very, very much science related when we talk about these trig functions and waves and things like that. So I said to you, first of all, amplitude we always treat as a positive number because amplitude is a measure of distance. Distance is never negative. Okay, and then the other thing that you need to know is that amplitude there's a formula for amplitude, maximum minus the minimum divided by 2. You need that because eventually we will be taking a story problem and writing an equation. So you'll need to be able to get the amplitude from words. It's the maximum minus the minimum divided by 2. So if we had, for example, I think this is what you're talking about, Grayson. Like if we had the graph of, that's very nice. Beautiful. -3. If we had the graph of 3 sine x, we know its amplitude is 3, but here's why. What's the maximum value? 3 minus what's the minimum value? -3, which in this case turns into 6, and then divided by 2 is 3. That's where that amplitude, that's how it would work out if we were doing it. It will be a little different as we get into some story from us.
I don't like how you're smiling about that. It's like the pod is just the pod.
Okay, so what I would like to do, I did not explain this well yesterday. We talked about trigonometric period, which was fine. I didn't really talk about tangent and cotangent. I just want to talk about them for a quick second. We will not be graphing tangent, okay? And I'm going to have you graph it on your calculator. We'll not be graphing tangent by hand because it's ugly, okay? So go ahead and just pop up a graph of tangent on your calculator. We're going to talk about it just a second.
Trevor, don't be a Debbie Downer, dude.
Okay, it should still be on Zoom Tree from yesterday, so you should still have a little bit of this. So sine and cosine really nice because they have defined maximums and minimums. That's what we really want to do with we want to graph this. So let's talk about we just want to talk about it. A couple of the features of this graph. What are these?
Yeah.
Asymptotes.
They're asymptotes. What kind? Vertical asymptotes. Those are vertical asymptotes. Okay, and so I want you to know why. What I would like you to do, use your big circle, and I would like you to find, not the sine, sorry, the tangent of pi over 2 using your circle.
Oh, it's undefined.
Use your big circle.
Use your big circle, Jason.
I don't have a big circle, so I'm
Oh, I
using
do.
a ring. That's not allowed. But I'm right, yeah?
0, 1,
Karma's
Okay, at 90 degrees, or pi over 2, the coordinate point is 0, 1. What's the tangent?
be 1 over 0.
It'd be 1 over 0, which is undefined. Okay, it happens again at, this is negative 90, which would be 270 degrees, or 3 pi over 2. 3 pi over 2, it happens there. Negative 90 degrees, it happens again, because at those coordinate points, it's 0, negative 1. Okay, and you end up with 0 on the bottom of the fraction. So every time that x value is equal to 0, you get undefined in this graph. Now, the domain of that then is really weird. His domain is not all real numbers. Because it has those asymptotes. Every pi that's divided by 2 has a added vertical asymptote there. Okay, what's his range? Range is all real numbers. Okay, because what happens on this vertical asymptote is this just continues to go down and down and down. So you can have an infinitely large tangent number. You can have a positive or negative. So I could have like the tangent. Oh, let's see if I can give you one here. So let's say you did on your calculator, if you're in radian mode, do the tangent of 1.5709. So you get big numbers. You can get big numbers out of that tangent. Because it just means you're really close to, this is really close to pi over 2. So that's weird. Tangent's just weird. Now, here's my question to you. Yesterday we talked about what a period was. A period is the amount of space it takes the graph to do a complete cycle. What's the period of tangent? Yeah, it's 1 pi. It goes from like a pi over 2, let's not do negatives. It goes from a pi over 2 to a 3 pi over 2. It has a different period than everything else. Okay, so tangent is straight up weird. What I want you to do, I'll leave my tangent up here. Nope. I can graph mine easier. You keep your tangent and I'm gonna switch mine to cotangent. And I just want you to compare. Okay? So, what's similar?
Backwards.
Okay, that was not similar. What's similar?
They still have
Still have the vertical asymptotes. Range still positive, negative, infinity. Still has a period of pi, correct? Now, what's different?
It doesn't hit 0.
Okay, it doesn't hit 0. It's reversed. Cotangent always goes down. Tangent always goes up. What else is different?
The periods.
What do you mean by that?
It's like 1 cycle behind.
So it's shifted a little bit. Yes. So the period is still pi, but it's in a different location. Tangent, I'll put them up here for you. I'll let you. It's a very nice graph. So tangent is a red one. So you can see that they're not in the same, like they're not in the same section of graph. Like if I drew the vertical asymptote for tangent, it's not where cotangent is.
But they intersect at 1.
They do, because that's the place where they're equal. Where the tangent and the cotangent will be equal. Okay, so go back to this paper. The period of tangent is pi. The period of cotangent was also pi. So these guys are different than everybody else. We will talk about cosecant and secant eventually. That's section 4.6. We will be graphing those. They are ugly. They're not hard to graph. They're just ugly graphs. But let me ask you, just to speculate, cosecant in terms of sines and cosines, if you wrote cosecant in terms of sines and cosines, what would that be? Cosecant is 1 over sine. What do you think the period is?
1 over 2 pi.
It's just 2 pi, which should make sense to you. If cosecant is related to sine, then they probably have the same period. So cosecant and secant have a period of 2 pi also, which, like I said, we will look at them eventually, learn how to graph them, but their period is 2 pi. Okay, so let's go back to talking about, we're talking about transformations. So the goal today is to get through A and D and then combine them. Okay, so by the end of today, you'll be able to graph a transformation that is just a change in amplitude, one that changes D, which we'll talk about what that's called in a second, and then graph them together combined, and then you'll have homework on that. Okay, so that's what we're up to today. So yesterday, you should have this on your stuff. We graphed 6 sine x, we graphed 0.25 cosine x, we graphed 10 sine x. The nice thing about these is that they look like their parent function. All you're doing is changing the amplitude numbers on the x-axis. Okay, so just for the sake of remembering the things, I'd like you to graph for me 4 cosine x. 4 cosine x, please. So, like, I want you to get yourself in the habit of asking these things to yourself, because eventually it's not going to be 2 pi for the period. One of our transformations will change the period. So you got to think to yourself, what's the end? What's the middle? So what's the end label on the x-axis? 2 pi. What's the middle? Pi. And so we don't need to number those guys. We need to mark them. What's the maximum this is going to get to? 4. What's the minimum it's going to get to? Okay, -4. And then cosine starts at its top, which you should have on your paper. Your other paper goes to the middle, goes to the bottom, middle, back to the top. So it's one complete cycle of cosine. There we go. Well, that's a pretty good one. Remember, not pointy, they're curvy lines, and so then let me have you do one more, and then we'll talk about what D does. So let me have you do 0.75 sine x. 0.75 sine x. Please and thank you. On your paper, Trevor. We're graphing by hand.
Jeez, Trevor.
Oh my gosh. Okay. So you guys, hopefully you look at this and you go, oh, this is really, like, you're doing the same thing every time. The only thing that's changing is your numbers that you're putting on your x-axis. So 0.75, negative 0.75. Sign starts in the middle. There you go. Okay, so hopefully you're like, this is fine. So what I want you to do, you don't have to put this on your paper, but I would like you to graph on your calculator y equals sine x plus 3. Y equals sine x plus 3. So you know what this does based on the other transformations that we've done. In first semester. What does it do? Shifts it up 3. Logical. Okay. What I would like you to notice, if I compare these guys, okay, what is similar? Amplitude doesn't change, right? The amplitude is, what's the amplitude of those guys? 1. Amplitude is 1, correct? That does not change because I didn't change the number in the front. Okay, amplitude doesn't change. Shape didn't change. There's no stretch there horizontally either. What I want you to notice is that the x-intercepts happen in the same, nope, I can't say that. The middle of the graph is here at 3 this time. Here the middle of the graph is at 0. You guys know what I mean by the middle of the graph? Like, it's this, where it would be 0 here, it's at 3 this time. So this guy crosses the middle. There's the middle. I'm just going to do that. Here's the middle. Crosses the middle at 0, at pi, and at 2 pi. And its maximums and minimums are also aligned in the same places. So we use that information to help us graph when we graph this by hand. So let's write stuff on the purple paper first. Okay, so that is D. So that is moving things up or down. This is D. Oh, that's not vertical. Crap. That's horizontal. Frick.
Up and down is horizontal.
No. Hang on.
Whoa. Shit. You having a stroke? That's not a good idea.
No.
Yeah, it's just
What is
I am having a brain fart. You guys, vertical. Correct, but we're moving it up or down. So this is a vertical shift. Okay. Okay. Just got second guessing myself because vertical asymptote is vertical asymptote this way. I got it. Up and down, vertical. Okay. So this moves up if D is positive. And it moves down if D is negative. Okay. So D is a vertical shift. A changes the amplitude. So we show you how to graph a vertical shift, the thinking that you need to do. And then we'll do a couple of those, and then we will talk about what happens when you combine them. Okay, so we're doing this, in case you need me to say it, Trevor, we're doing this on paper. So let's say we're going to graph y equals the sine of x plus 2. Now, your x-axis does not change. Stop talking, please. Okay, x-axis does not change. So those same 5 points, the 0 is your fifth one. The x-axis does not change here. What you need to do is imagine, you can do this 2 ways. I'm going to show you the way that my brain likes to think, and then I will, if you don't like it, you can tell me and I'll show you the other way. Okay? All I'm going to do, I'm going to draw a dotted line here at 2. Okay, so if I shift my graph up 2, then I'm going to treat that dotted line as my x-axis was, right? So from here, sine starts at the middle would be at 2. It goes up 1 because its amplitude is 1. It goes back to the middle. It goes down to its minimum, which would be down 1, and it goes back to its middle. So by drawing that dotted line in there, I basically don't have to think once I do that. I treat it like the x-axis, and I put my 5 points are just around the line at 2 instead of the 0 at the x-axis. And then there's my graph, which is the graph of sine x plus 2. Some people can do that without putting the dotted line. I like the dotted line. It saves me a headache, especially with what comes in a minute. Okay. Do not put this on your paper unless you want to. Your other option would be to draw in the original points. So draw in regular sine, which would be those 5 points right there, and then shift everything up 2 places, because that's what plus 2 would do. It would move everything up 2. So you would go here, you're going to go from this guy up 2, this guy up 2, this guy up 2, and this guy up 2, and then you would have to draw that. This saves time. They end up in the same place. This is still 2, this is still, this is 3, 2, and 1.
I could both those.
Okay. This needs to have a couple more labels on the y-axis, because I have a maximum that's not at 1, and I have a minimum that's not at -1. So I need to label those x-axis, y-axis numbers now, because they're important. Okay, we've got them on this graph. Our graph of our original is 1, -1, 0. We don't have to label because, sorry, there you go. 0 is 0. So it does not matter to me which way you do it. I would personally recommend this because it's going to get dicey in a couple minutes. Okay, so why don't you try y equals cosine x minus 1. Okay, cosine x minus 1 without your calculator, gentlemen. I was talking to you, was I?
Trevor, another anybody.
I wasn't.
What are you doing?
I'm not finished.
Great, please grab by hand.
I was.
No, you weren't grabbing by hand. You're grabbing with your calculator.
When you go down.
Whoa, Weston. Why can't I just write 2 on where the x-axis is?
Because that's not where the x-axis is.
Well, what if I just make it?
Then I'll mark it wrong.
Start negative.
I don't want to do that.
Too bad. That's the way we're doing it. What is the vertical shift here? Down 1. So you either need to start with your original cosine graph and move everything down 1, or you need to draw your x-axis, because you got to do that anyway. And then put your dotted line at -1, and then treat that as your x-axis. So what is the maximum that this gets to? 0. What's the minimum it gets to? Yep. So cosine starts at its top. So top, middle, bottom, back to the middle, back to the top. There's your graph. That is cosine x minus 1. So cosine x graph dropped down 1. What are your questions on that? Okay, now we're going to combine the two. Grayson and Javon. Put your calculators down. Thank you. I am happy that you're being quiet. That's not what I asked. Let's do I like sine better. 2 sine x plus 4. Okay, now let me tell you why I feel like the dotted line way is the best way to do it. Okay, so I'll draw my x-axis on 2 pi, 1 pi, whatever. If I get, what's the vertical shift on this? 4, so it moves up 4. If I do that, then I can ignore the fact that it's moved up 4. It just lets me have a little more operating brain space. Now, so this is 4. What's the amplitude on this guy? 2, which means that sine, he's going to start at his middle, and he's not going to go up 1. He's going to go up 2 because the amplitude is 2. So I'm starting here at 0, and then I'm going to go up 2. So that puts my maximum at what? 6. And then I'm going to go back to the middle, which is my dotted line. I'm going to go down to the bottom with an amplitude of 2. So what's his minimum? 2. So they go down there, and then we're going to go back to the middle. So by marking that middle, it lets you deal with the shift, and then you're done. You can put it out of your mind and just graph 2 sine x on that line. It just makes it a little bit easier for you to do. Oh, this is not a very nice graph.
My graphs are so bad.
That one was pretty ugly.
Oh my gosh.
Don't look at that.
Oh.
It's not like you're doing it, Connor.
Guys, don't
I'm
look
doing it
at
in my
that.
head. So
Oh, that'll make a difference.
Really?
So let's
Yell
go.
at us if you're not calculated, but you're not gonna yell at Connor for not taking notes.
I'm being quiet and listening.
We were being quiet and we were listening.
Yeah, but
No,
doing
you weren't.
You were doing something you weren't supposed to do though.
You're
Oh,
doing
my
nothing.
goodness.
You're supposed to take notes.
I'm doing nothing. I literally can't be doing anything. I'm doing nothing.
Exactly.
Okay, why don't you try 5 cosine x minus 2.
I'm not refusing to take notes. I'm just not taking them.
That's not
Like if she made me take notes, I would do it.
It does.
But she doesn't.
But she doesn't care because he's being quiet and actually listening.
And I'm like, what am I doing?
He is at least paying attention to what I'm doing in class.
Yeah.
That's what I'm saying. You were drawing lovely pictures on your note.
Exactly.
Shut up. You're in the Gold Star Club, he's not. I feel like that is case in point. I totally just told you to shut up, sorry.
Yeah. Very nice. It's starting to sound like we're wrong.
I want to take that.
Cosine starts at the top. Okay, well, it's what's his amplitude? So he's got to be 5 above that line you just drew. So if you drew your dotted line at 2, -2,
Oh, we're gonna go
3.
way above.
yes.
C.
At 2.
3.
3 because it's 5 above, right? So from here to there, so your top has to be 5.
I do.
That was nice of you to check on him.
No, because he told me he needs help. Someone out.
Bang.
So it's gonna
You want to draw this?
at 5.
How'd that work out for you? How'd that work out for you?
It will sort of, since you went down to it, will sort of
Not so well. Okay, I'm kind of,
go across in the middle and go
I know this.
down to 5.
Is this your graph? It's wrong.
Oh,
You gotta label the bottom.
I think I did it. Okay.
Or something.
Yeah, this is sketchy.
Why aren't you draw that down the line?
I draw the dotted line.
I was not doing this. I tried it.
That is.
Ooh.
Is that a-
Guess what?
I think that's right.
That's wrong.
It's right in the green.
See, this is why I pay attention.
I would pay attention.
Oh, my word.
I just don't like
Did I
drawing.
get my
close.
graph wrong? I don't think so.
Person that asked me, I don't think so.
Oh, that's a fair point.
Did I give it anyway? Like,
I
usually
don't
three.
like that.
Okay, what's the vertical shift on this?
Down to.
Down 2.
I'm letting you mix.
Okay, so again, make that take the place of your x-axis and you don't have to worry about it. Amplitude of 5 means that it's going to be 5 above the top and 5 below. Sorry, let me try that again. 5 above the middle and 5 below the middle. So what will be the highest? What will be the highest this gets to? Positive 3, because you're starting at -2. You got to have the space of 5 in there. So this is going to be 3. What's the lowest it gets? -7. Now you can, honestly, this is here only for its labels. Okay. But it needs to stay there because it's an x-axis and we have graphs. We have x-axes on our graphs. But cosine starts at its top, goes to its middle, goes to its bottom, goes to its middle, and goes back to the top. Notice that these are happening at 0, pi over 2, pi, and 3 pi over 2, which is why you have to have those marks on your x-axis, because it gives you where the things happen. They're just happening at -2 instead of, oh, there you go.
No, mine only had 3 lines instead of 4.
Okay.
I graphed it and everything.
What questions do you have right now? I'm going to give you homework and just let you try it. Otherwise, I'm just yapping at you, and that's not always helpful. Okay, so I'm going to give you your homework.
When did we get to the I mean, you're not gonna skip these.
If I take calculus, then we get to do
We did a little bit of that.
Almost Douglas, you probably had enough. This is not the word
Dude,
Why would I?
because you need a senior.
Then you can just say,
What's
I
the
think I
matter?
Is it really?
It is.
Yeah.
Okay, if you are in Gold Star Club, you may cross off number 2. You may cross off number 6. I get rid of one more for you. You can cross off number 9. 2, 6, and 9 you can cross off for a Gold Star Club. Okay, this is the time for you to ask for help if you need it. I would love to come and help you if you need some help. So just ask.